This lesson is about finding outcomes. 4 band members, Harry, Isabel, Jose, and Karen, are all boarding a bus to attend a concert. In each arrangement below, the first initial of a person's name represents that person's position as he or she boards the bus, first, second, third, or fourth. If we know that Karen boards the bus first, which shows the possible outcomes for this event? Okay, I guess we're just going to make a list. So we're using the letters H, I, J, and K. Alright, we know that Karen boards the bus first. Alright, so no matter what, we're starting with K. Now, let's talk about the possibilities if let's see, Harry goes second. So then it would be Karen and then Harry. Okay, and then after that, it will either be Isabel and Jose, or the other way around. Okay, so I'm going to have, let me just put a bunch of K's down here. Alright, I'll put more if I need them. Okay, so if Harry goes second, then it will either be Karen, Harry, Isabel, and Jose, or Karen, Harry, Jose, and Isabel. Okay, now what if Isabel goes second? Alright, now if Isabel goes second, then the remaining options are, okay, if Isabel goes second, then that just leaves Harry and Jose. So it'll either be Harry and Jose, or Jose followed by Harry. Okay. Now, what if Jose goes second? Alright, if Jose goes second, then that just leaves Harry and Isabel. So it'll either be Harry and Isabel, or Isabel and Harry. Okay, so these are all of the possible outcomes. Karen went first. After that, either Harry went second, or Isabel went second, or Jose went second. So there are 6 possible outcomes in terms of the order. So let's look and see what we've got. So only one of these choices actually had 6 outcomes listed. 1, 2, 3, 4, 5, 6. And if you study them carefully, you will see that these 6 outcomes match what we came up with. Helena has 5 different flowers. She plans to give 1 flower to each of her 5 teachers in any order. She gives the first flower to one of her teachers in the morning. In how many different ways can she give the 4 remaining flowers to the rest of the teachers in the afternoon? Alright, well, this business about 5 flowers is over quickly because she gave 1 away in the morning. So we are really just talking about 4 flowers and 4 teachers. So let each one of these dashes represent a teacher. Okay, and I'm going to let the letters A, B, C, and D represent the 4 flowers. So for example, the first teacher could get flower A, and the second teacher could get flower B, and so on. That's one way it could go. Or it could be, D, C, A, B, that's another way, etc., until we got all the possibilities. But to do this efficiently, we could use the fundamental counting principle, which means if we look at how many ways there are to do this, then we can just multiply. Okay, so how many choices are there for the first teacher? Okay, there are 4. So there are 4 ways it could go for the first teacher. Now, once the first teacher gets a flower, though, how many ways are left for the next teacher? All right, that leaves 3 left for the next teacher, which leaves 2 flowers to choose from for the third teacher, which means that the last teacher, there's only 1 flower left. So if I multiply all these out, that should give me the total number of ways this could have gone. So 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. Times 1 is still 24. So that's 24 combinations. Kabam! A dance instructor chose 4 of his 10 students to be on stage for a performance. If the order does not matter, in how many different ways can the instructor choose the 4 students? Well, when the order doesn't matter, that's when we do combinations. And so we say 10 combination 4, or sometimes I'll say 10 choose 4. And because there's a total of 10 students, but we're choosing 4, and the order doesn't matter. And they were kind enough to give us the formula here to use. So, I guess you have to know what factorial means, or at least how to do it on your calculator. So, once you have this situation, this is sort of the definition. They're showing you how to set up a combination. All right, there it is. But you can use your calculator. I mean, that's the bottom line. And I'm actually going to show you 2 things real quick. One of them is the fact that combinations appear on your calculator here in item number 2. So what you want to do is, since we need the 10 and the 4, you put the 10 first. And then you hit that probability button and you choose option number 2. And then you put in the 4. So this is your calculator's way of doing 10 choose 4 combinations. So that's 210. That's how you do it. There also is a factorial key in your calculator somewhere. So if you wanted to do it the long way, you could set up your fraction and you could do 10, and I think it's under here again. Yeah, see that third choice there is the factorial key. And then we could do the 10 minus 4. Oops, I missed. Okay, we could do 10 minus 4. And we need that factorial again. And then 4 factorial one more time. Okay, so either way you get 210, but obviously the first way I did it is the fastest. Okay, that's why it's 210. 3 out of 7 students in the cafeteria line are chosen to answer survey questions. How many different combinations of 3 students are possible? So they're telling us combinations, okay, so the order doesn't matter. Now, did they really give you this calculation as part of the problem? Because it seems like they're just giving away the answer if they did. I'm not sure if they gave you this or not. If they didn't, hey, they're choosing 3 out of 7. So notice that the 7, goes first, and the 3 goes second. 7 choose 3 is the way I like to say it. If they give you that, then the problem becomes ridiculously easy. You just put in the 7, go to your probability. Item number 2 is for combinations, and then you put in the 3 next. Okay, so that's 35. Alright, so you have no excuse for ever missing a problem like that. Okay, let's see. A membership committee of 3 is formed from 4 eligible members. Alright, 3 out of 4 members. Let the eligible members be represented by A, B, C, and D. The possible outcomes include, there you go. Which statements about the situation are true? Check all that apply. Okay, let's see. There are 4 ways to choose the committee. 1, 2, 3, 4. Yeah. There are 3 ways to form the committee if person D must be on it. Well, let's see. Person D, person D, person D, no person D. So yeah, I count 3 ways that have person D in it. Okay, if 7 members are eligible next year, then there will be fewer combinations. Well, that doesn't make any sense at all. The more people you have, the more options you're going to have. So there would be more. Hopefully that's just common sense to you. If person B and C must be on the committee, there are 2 ways to form the committee. Let's see, B and C. Nope. Nope. B and C. Yep, I count 2 ways that could happen. If person A and C must be on the committee, then there is only 1 way to form the committee. I have a feeling that it's going to be 2, just like when it was B and C. Alright, there's A and C. Nope. There's another A and C. Nope. So that's false. 1 way. No, that's false. There's 2. So these should be the 3 correct answers. And there you go. 8 students are competing for a blue, red, and yellow ribbon for their agriculture project. How many different ways are there to present those ribbons if the order matters? Alright, there are 8 students, but only 3 of them, blue, red, yellow, only 3 of them are going to get a ribbon. And the order matters. So when the order matters, we are talking about permutations, not combinations, but permutations. So there are 8 students, and of them we are picking 3. So this is what you're going to use. Alright, 8 pick 3 permutations. That's why I said pick instead of choose. And I'm just going to use my calculator. Okay, so if I want to do 8 pick 3, I do 8, and I'm going to choose option number 1, and then I'm going to do the 3. Oh, there's 336 ways that could go. Boom! In how many ways can the letters in the word spoon be arranged? Let's see. We have 1, 2, 3, 4, 5. We have 5 letters. So the total number of ways that those letters can be rearranged are 5 factorial. However, 2 of the letters are repeated. So we're going to have to divide by 2 factorial. Alright, this 2 factorial represents the repeated letter. Alright, if there were 3 repeated letters, then I would have put 3 factorial. Alright, this is a way of getting rid of the duplicates. When you have repeated letters, then you have this situation where when you do 5 factorial and it's giving you all the different arrangements, it's counting, you know, like here I've colored the O's so I can say spoon with a pink O and a green O, and then spoon with the green O and then the pink O. I did that so you could see me rearranging the O's. But really we don't have color, so both of those different options would really look the same. So you cannot count these as 2 different options. you really have to count them as only one. So that's why when you have a repeated letter, you have to get rid of the extras. And this, you get rid of them by dividing by the number of repeated letters factorial. Now I can do this in my calculator. Alright, I can do 5 factorial over 2 factorial. And that's going to give me 60. But I think it would be helpful to point out that 5 factorial means 5 times 4 times 3 times 2 times 1. Okay, and 2 factorial means 2 times 1. So I could just cancel out the 2 times 1 part, and that leaves 5 times 4 times 3. 5 times 4 is 20. 20 times 3 is 60. So you should be able to do it without a calculator. Alright, this will be the last problem. How many ways can 8 letters be arranged into groups of 5 where the order matters? If the order matters, that tells us we're doing permutations instead of combinations. Okay, permutations. Let's see. 8 letters total, and we're going to make groups of 5. So that means we're going to do 8, pick 5, the order matters. So I'm just going to do this in my calculator. So I put the 8 first, and then I do option number 1 is for permutations, and then I do the 5. That's 6,720. Okay, that was an epic fail. That's what I get for not reading the question all the way. So it says 8 letters can be chosen we're doing groups of 5, so I said 8, pick 5. But then at the end of the sentence it says the first 2 letters are already chosen. I didn't read that part. I got carried away. If 2 letters are already chosen, that means we're not really dealing with 8 and 5. Okay? 2 letters are already chosen. So we really are dealing with 6 remaining options, and we really are only picking 3. Okay? We had to take 2 away from both of those categories. So it's really a 6 pick 3 situation if you take away 2 letters already chosen. Okay, so 6 pick 3 should do it for us. So we'll do 6 probability, first option for permutations, and then 3. So that is why it is 120. Also, we could have done the fundamental counting principle, still being careful to read the whole sentence. If we're making groups of 5, okay, keeping in mind that we started off with 8 letters. Okay, so we had 8 letters to choose from for the first one, and then we had 7 to choose from for the second one, and then we had 6 to choose from for the third one, and then 5 for the fourth one, and then 4 for the fifth one. But the first 2 are already chosen. Okay, so it's really, we're down to this 6 times 5 times 4. 6 times 5 is 30. 30 times 4 is 120.